Hi everyone. This is Iyad Mari from Keplerworks, and I'm going to take you through today's presentation on serverless. First, I would like to thank you all for attending this webinar, and I hope you will enjoy the knowledge with us. I think let's start now. Okay, our agenda for today will speak about first quick introduction about what is serverless, why serverless, advantages, and then we'll go to some serverless architecture patterns. After that, we'll speak a bit about our experience as Keplerworks with serverless, business case from our projects. After that, I'll speak about, there will be there also some little bit of technical dive there. I'll not make it, we'll try not to make it very technical. So to cover both the business perspective and the technical side of it. After that, we'll conclude, we'll speak about the challenges with serverless and discuss when is it good fit for you. And we'll take questions towards the end of this session. If you have any questions, please post it in chat, and we'll try to take it towards the end of the session. Okay, we'll start with this slide just to position the advantages of serverless. This is a quote from Andy Jassy, the CEO of Amazon Web Services, saying if Amazon.com, the retail site, were starting today, it would go serverless. And that starting that's an introduction. That gives us an idea about how is a new shift today towards serverless, and many people are thinking it's the future. And we will take you through some advantages of this architecture change and maybe culture change as well. So let's start with defining it. Serverless is relatively a new topic, a new domain. There is no very specific definition for it, but as AWS define it, is serverless computing allows you to build and run applications and services without thinking about servers. So the name, the serverless here comes because a lot of people ask also us about what do you mean? Is there no server? It's actually that you don't have to care about servers. This is how we think about it. There are servers and infrastructures under the hood, of course, but the bottom line is you don't have to think about these servers. Serverless applications don't require you to provision, scale, and manage any servers. It's all managed by the cloud provider, by AWS for you. You can build them for nearly any type of application or backend service, and everything required to run and scale your application with high availability, which is a key for serverless. Generally, if you want to visualize it, it looks like this, and some people calls it like function as service. So you have the infrastructure and the platform, and on top of that, you have your functions. And with serverless, all you have to worry about really is your functions. And the idea is to make you more focused on your business challenges and your business cases, and don't worry about the infrastructure and even the platform. Amazon views serverless as the native architecture of the cloud for many benefits, like no provisioning and no management. It's almost no management because you don't have to worry about managing any servers, any load balancer, any performance bottlenecks. Also, it's automatically scaling for you. It will automatically scale because it runs under the hood on a small what we call containers or virtualized environments, and it automatically scales by the number of requests you receive on your application, or API calls, or the load on your application. You pay for value, and we'll see how is that. It's highly available and secure as well. One of the main advantage of that is the agility. And this is a quote from a company called Edmunds, who implemented, who done a big transformation towards serverless. And what they're saying is it took us just a few days to build a using serverless solution based on AWS Lambda, which is a functional service from AWS, which would have taken them 6 months to build it from scratch. Elasticity. The financial engine, which is another company, also experienced near zero downtime and near zero performance degradation while serving 200 to 30 million IPO requests per month. One of the key advantages which we see for serverless is its elasticity, because you don't have to think, you don't have to guess your capacity, as AWS always says, with the older generation, or with the first era of the cloud, also that was there with the infrastructure as a service, because you have the elasticity of provisioning new servers, but you still had to think about how many servers you want to provision, and how and reserve, and all of these things, and you put like something like auto scaling mechanism there. With serverless, you don't have even to do that, because everything under the hood will spin up for you automatically. Once you load goes up, it will be elastic, and it will automatically provision new containers or new infrastructure under the hood for you. Total cost efficiency, and this boils down to many things. This comes from many factors actually. You don't have to over provision any servers, and you don't have to pay for idle time if your load is not really utilizing your infrastructure, whether it's on premise or on the cloud. Also, the size of your team is half of what is normally needed to build and operate a site of the scale of Ferna, which is another company also who is running on serverless now. And they are saying that we have increased cost efficiency by a factor of 2. So those are some of the main advantages of serverless. We'll take you through them in detail also as we go now. The serverless world in AWS contains a lot of offerings. So you have on the left, you have some of the managed services from AWS, like RDS, Relational Database Services, Elasticsearch, and Amazon Redshift. And on the right, you can see the serverless offering by AWS. And on top of that, and the key one is AWS Lambda, which we'll talk about a bit in detail in today's session. Which is a function as a service. But along with that, you have many also other services like Cognito, which is used for authentication, Amazon Kinesis for data streaming, Athena, which is a query service which allows you to query based on the data size and the number of queries without provisioning any database engine here. And one of the key things also is Amazon DynamoDB here, which is a serverless NoSQL database, which the pricing model with DynamoDB is also serverless. That means you pay for your read and write. You don't have to think about servers again. Or database size or table space, or all of these factors which you consider when you are going for normal database, relational database, or other type of databases. Amazon S3 also, which is the Amazon Object Storage. If you are not familiar with it, you can imagine it's something like any drive which you have on the cloud, like with Apple or with Google, but it's a storage, object storage, which is suited for corporate and for business, with very elastic offering as well. Microservices works well with serverless, and this is something we will speak about when we speak about the culture change. Serverless and microservices goes well together, because serverless works as a set of functions around your services, and a microservices also as an architectural change involves dividing your monolith application or your big application into a subset of services. And that will let you focus on your application rather on your other infrastructure or operational or logistics costs. Okay, at the key of serverless computing in AWS, we have Lambda, which is the function as service from AWS. And that was one of the first offering in the serverless spectrum from AWS. In Lambda, you go to the can go really just to the console and write your function, and you don't have to worry about anything else. It supports different languages. It supports Node.js, Python, Java, C#, and Go, PowerShell, and Ruby. And it works like it can be triggered by event sources. Any changes in the state, whether it's on cloud or on your premise, you can just trigger Lambda function there. And if your infrastructure is on the cloud or your applications on the cloud, it can directly communicate with Lambda. If it is on premise, you can communicate with Lambda. Usually, the pattern is using API gateway, which you publish your Lambda function on a web service, and that web service will talk to Lambda. So it's kind of event-driven, also event-driven programming. And you have Lambda in the middle, which is which have your business logic and your validation, for example, or your data retrieval, etc. And it can talk almost with any services in AWS. You can configure it and you can develop it to work with any database in AWS or any service like S3, which is a storage, or even with application servers if it's running on AWS or outside of AWS as well. It's a little bit more technical here. We're talking about the anatomy of Lambda function. So inside the Lambda function, you have the handler function, which is kind of the main function. It has to be there in any Lambda function. And it looks similar to the main function in other programming languages, for example, like C or Java, which is your main function here. And accepts like the event and the context, and then which is the event which is triggering Lambda. Let it be, for example, a Facebook message or an API call, and the context which contains the details of that payload. Some of the advantages of AWS Lambda is you can bring your own code. So you can write your own code using either any of these Node.js, Java, Python, Go, etc. And you can bring your own libraries and package it and upload it to Lambda. And also one of the advantages is that you can develop adopting the serverless model with API and web services. You can really, if you have team from different skill sets or programming languages background, since it goes also with microservices approach, you can, some of your team can be writing part of your application using Python, for example, and some of them will be writing your application using Java. Because everything is packaged around microservices and it's loosely coupled. And so this is one of the main advantages we see for this approach as well. It's flexible to use. It can be either synchronous or asynchronous, and integrated with other AWS services, natively integrated with DynamoDB, for example, the NoSQL engine, with RDS, with S3, with really almost all AWS services. Simple resource model. You can select the power rating. You can select your memory. You have the flexibility to select between 128 GB to 3 GB for your execution. And this 128 GB or 3 GB, when you have to think about it, you have to think about how much the instance of your function, the execution of your function would really need. Most of the people go with 128, 256, or 512 MB. I think rarely you will need 3 GB because this memory will be allocated to your function call. So it's only allocated to that very one call of your, let it be an API call to an e-commerce website for a customer, for example, who is browsing your catalog item. So that itself is one function call. So you have to think when we provision Lambda, we have to think about that call, that instance of that function, how much memory would take. So it's flexible between 128 GB to 3 GB. If you have really something intensive, maybe data retrieval or analytics workload or something like that, so CPU and network will be allocated proportionately to this automatically also. You have capabilities to secure and grant access resources in your VPC. VPC is a virtual private cloud in AWS, which is kind of your network on the cloud. So you have all the capabilities to securely grant access from the Lambda function using the identity access management of AWS. You can control what Lambda function can access in your resources as well. So there are roles which you grant to this function to control the access. Sometimes you will allow it to access your database, for example, but not access your main server, for example. There's a lot of IDEs and programming models. Cloud9 is an IDE provided by AWS also, which you can use it to edit your function. There is also, you can use your own SDK as well, or the serverless application model, or you can either write your Lambda function on the cloud directly, or you can write it in your IDE and package it and upload it to AWS Lambda. It's also stateless, which is a big advantage. Persist data using external storage, no affinity or access to underlying infrastructure. Everything is stateless with Lambda. So once you run the function and it finished the execution, everything will end. So that also reduces the overload in the memory and the compute, which allows you to provision less memory and compute for that. And any persistence has to go in a storage like S3 or seshing cookies at the browser, for example. This is one example of the pattern, serverless architecture pattern. Here we see weather application. For example, it's just a sample application in the front. So it's a complete web application running on serverless. On the front, you have your website will be sitting on S3, hosting your web pages on S3, which is also completely serverless. With S3, you pay only for storage. You don't pay for resources or memory. Your website will be a set of web pages, which we call now single page applications, which is a JavaScript pages, for example. And in this JavaScript, the code will be calling an API deployed on the AWS API gateway. So it could be your RESTful service, which is, for example, retrieving your customer, published on API gateway. And from API gateway is natively integrated with Lambda. Your RESTful service will be linked to the Lambda function, which will do the actual work like retrieving database record from DynamoDB. This is a typical serverless architecture where, for example, your customer record, your product items are sitting in DynamoDB. You are not provisioning any database memory or resources here. You're just paying for read and write on DynamoDB. And then the Lambda function will be retrieving these records from DynamoDB here, and then responding back through your API gateway to your user who is clicking to get the local weather or clicking to get the product catalog or whatever. So DynamoDB here, just let me elaborate more. DynamoDB is the NoSQL database of AWS. And there you can, it's very elastic. It's completely serverless. That means you don't have, as I said, to provision memory or CPU. It charges you, the pricing model for DynamoDB works with read capacity and write capacity. So you have really to think, what you have really to think about how much reads and writes I will need each month for this table, and based on that, you conclude your pricing and your capacity. Uh, And then in front of Lambda, the API gateway is the engine for publishing your web service. Practically speaking, you'll be, for example, for a database application, you'll be creating a table for your application. Let it be, for example, e-commerce. You put all your records there, product catalog, customer records, all of that. And after that, you put, you configure, you develop Lambda functions using any programming languages like Python or Java or Go. As we discussed, Lambda supports a lot of programming languages. And the code here will be using the SDK from AWS to access DynamoDB to query the records, for example. And then it will communicate back to API gateway. It will be published as a web service using API gateway. So for example, a RESTful service, which is reading your product catalog, will be with a URL. You specify / for example, get products as a RESTful service, and that get products API will be talking to this Lambda function, which will talk to the DynamoDB also. Since DynamoDB is a core of the serverless pattern, you have also to think about how you model it. It has get item, put item functions, APIs, which comes with the SDK for DynamoDB from AWS. But what really you have to think about if you are shifting to NoSQL engine like DynamoDB from our experience, is you have to think about your access patterns for DynamoDB, how you will model your data. Because it's quite different than the normal relational database, which makes it a little bit challenging at the beginning. In DynamoDB, the general guideline is you have to store almost all of your application in one table. So your customers, since it is a key value pair, NoSQL, it does not really care about schema. It's schemaless. And with NoSQL engines, usually you have to store everything in one table to address for performance. Because DynamoDB works well when you put everything in one table. Once you start distributing data over tables, you have a bit of performance problems here. So modeling all of your schema inside one table is one of the challenges which we see when we are shifting from relational database to DynamoDB. There is no relation here. There is no concept of relation. There is no normalization. It's completely opposite way of thinking. And you can think about it as write is cheap, read is expensive. So write a lot, but avoid expensive read operations and query operations between tables. Try not to join two tables together if you can. Try to avoid complex query joins, because it works well with one table. However, Lambda does not have also always to talk to DynamoDB. You can still store your data on normal relational database service like Oracle or SQL Server. But the reason why we would propose DynamoDB usually, because it was cheaper with serverless application. Again, you don't have to worry about provisioning this amount of memory for your database or this amount of CPU for your database. What you really have to worry about and think about is how many records you have and how many transactions you want or you are expecting for your website or your application. This is an example of one application we built also for on serverless. It's a chatbot application. Generally, what it does, it's a fleet management system. It's a GPS tracking and fleet management system. So what this company asked us to build is they have a platform for fleet management. They have a lot of cars running on that system. And they have a map. You can imagine it like Google Map. And they ended up having thousands of cars on that map. So what they wanted to do is, instead of that complex GUI, they wanted to build a chatbot on top of that GPS system to do something like when they are monitoring their cars, their team can just easily speak to that system, saying something like, where is my BMW X5, and for example, and then it will get the location for that, or what is the plate number of that truck, which is model, etc., etc. So that they thought about that as a conversational interface for their complex fleet management system. So the way we built it for them is we use Amazon Lex here as a chatbot, and on Amazon Lex we built all of these conversational interface. On front of Amazon Lex, we have the Lambda function. We have the Lambda function integrating with the APIs of the fleet management system here. And on the right side, you have a chat channel. So the user will be sitting on a chat window, asking the system, where is my, for example, Toyota Camry number 10, for example. And then that chat channel will call an API from the API gateway. From the API gateway, there is a RESTful service published, which will talk to a Lambda function, which will take the request of the API, talk to AWS Lex, which is a chatbot here, and the chatbot will comprehend the statement and will understand it, and then call a Lambda function which will talk to the API of the fleet management system, because that fleet management system is a third-party system and it has an API published to get the location. So the flow will be again from a chat channel, get me where is the location of my BMW X5. That chat message will go into through an API to a Lambda function, which will talk to Lex. Lex will understand the meaning of the statement and the intent, what we call an intent in the chatbot language. It will validate it, and then it will invoke a Lambda function, which will call the API. The API will respond back with coordinates, for example, X and Y. Going back to Lex, Lex will understand and will rephrase it. Your location is this X and Y, and it will go back to the chat channel. So this is one of the example of our implementation with serverless architecture. Now, one thing we have to think about mainly with Lambda is the pricing here. And many developers, technical people, you usually think about serverless and Lambda function as a number of requests. When they think about the pricing, they really think mainly about the number of requests. So on AWS, the number of requests you have for Lambda, if you have 1 million requests, it's around $0.2. It's $0.2 for 1 million requests. But also you have to think about duration. So AWS will charge you also for the GB second which your function took in executing. So as you see here, for each execution second, for each GB second, this is a cost. It's really a fraction, tiny fractions of dollars. But when you do calculate it, sometimes if your duration goes up, it will really affect your pricing as well. You have to think about memory also, because AWS will charge you for memory. And as we said, you have to think about how much memory your single execution of that function would really need. And it has different pricing for memory here. So for 128, 512, 1024, all of that are different pricing. All of that together conclude the pricing of Lambda. You can go to the calculator also of AWS. If you enter your variables here, you can factor in all of these variables here to conclude your pricing. But the main thing is to think about is the challenging thing is to find a sweet spot between the duration of your function and the memory, because sometimes when you increase your memory, you really lower your execution time. But you have to spend some time in designing and thinking to finding the right balance between the memory and the duration. As we said, microservices allow you to decompose for agility, and serverless goes well with microservices since it's a separate set of functions packaged around your service. Let it be get your customer or get your managing your customer or managing your product catalog or managing your sales. The challenges some of the challenges you have to think about when deciding whether serverless is the right fit for you. You have a design change. So if you have a ready application running, sometimes you have to think well about how you will change the design because it's not a one set of application running in one box with one code base. You have to really spend some time in code transformation to transform this application into a set of Lambda functions, for example, running on AWS. Management and control here becomes also a challenge. How do you manage all of these functions written in an independent, sometimes scattered on AWS? You have to carefully manage and control that in AWS. It's a challenge also about how to do monitoring of these functions. Pricing is also one of the challenges. Some people would argue that serverless ended up being more expensive than they thought. But as we said in the first slide, in the previous slide, you have to be careful about how you price it here. You think about your request, your duration, and your memory allocated to that. Also, on top of that, you have to account for other charges like API gateway, for example. In our previous slide here, we see also API, we use API gateway here. So most probably, in most of the cases, in many cases, your AWS Lambda will be exposed to the world using Amazon API gateway. So you have to think about also your API gateway costing. It charged around $3.2 for something like that, around for 1 million requests. So this cost also should be involved in your calculation, as well, and also the cost of your database on DynamoDB, uh, which has its own pricing as well. But the rule of thumb we have at Keplerworks for this, we start thinking about your workload, and generally, if you are not utilizing your server 24 hours, let's say if you are an e-commerce website which you have a peaks at daytime or near public holidays or Black Friday or Christmas, and then your server are sitting idle for a good amount of time, then probably serverless would save you a lot of money. Uh, if you are utilizing your servers like almost 24 hours, we had a case like that for a GPS tracking system again for another company, which are running on AWS on relational database service, and their devices are sending messages every 30 seconds. It's around 2 millions of message every second. In that case, you have to think twice about moving to serverless. You have to calculate the price carefully because sometimes it will end up being similar cost or maybe expensive. But also, when we think about serverless, you have also to think about that it's not the infrastructure cost only. Think about the admin time you are saving, the operational time, the size of your team, the bottlenecks which you are avoiding and you don't have to think and plan for. You don't have any bottlenecks for like something like which if you load is suddenly going into spike. All of that is managed by AWS for you. You don't have DBA time, which is managing the DBA or provisioning new table space or monitoring the database. So all of that, it's a culture change that you have to shift when you go to serverless, along with maybe adopting microservices approach to work well with the serverless. And that's really it. Thank you. We'll take some questions if we have now. I think we don't have more question, Verma. We can end it here. Uh, Thank you all for attending. Uh, okay, Verma. We can end it here, and thank you everybody for attending this session, and hope to see you in the future sessions as well.